So in section 14.2, we work more with the writing of the recursive and explicit rule. And you did this with some success in September-ish of the year. And now you're doing the same thing, only the rules are slightly different, simply because instead of arithmetic sequences, we're working with geometric sequences. So it's a little bit different, but a lot of the concepts are still the same. You still need to know what f of 1 is, right? And now instead of looking for d, we have to find the common difference. You'll recognize this, f of n minus 1. That stands for the previous term, right? And it's all going to be multiplied times r, where r stands for the common ratio instead of common difference, common ratio. And for the explicit rule, it's a similar concept. We still need to know what f of 1 is. And then we need to take whatever f of 1 equals and multiply it by the common ratio to the n minus 1 power. And what that means, n is like f of 1. For f of 1, n is 1. For f of 2, n is 2. For f of 3, n is 3, and so on. So I hope that makes sense. So whatever particular term, if you're looking for the 456th term, your n would be 456, and then you'd subtract 1 from it, and that's how high you would raise the power of r. So this is just for your understanding only. It's good if you wrote it down though. But basically n is just whatever term you're on, right? And down below you'll see more examples, like n will be 1 for the first term, 2 for the second term, and so on. Now, the other thing I need to call out in this section is when we were doing arithmetic sequences, we talked about f of n, right? And then you were finding f of 1, and you wrote things in this fashion. There's a different kind of sequence notation, and we're going to introduce it now in this topic, or in this chapter. F of n is the same as a sub n, and f of 1 is the same as a sub 1. So there's just two different ways to notate this, and you need to know that they are essentially the same thing. So I don't want it to throw you off, right? So like if n is 1 and f of 1 is 5, a of 1 is also 5, right? It's just a different way to write the same thing. So let's do an example here on this. We know, if you take 20 divided by 5, and 80 divided by 20, and 320 divided by 80, and 1280 divided by 320, you're going to get a common ratio, and that ratio is going to equal 4. And we know that f of 1 is equal to 5, right? It's the first number in the list of numbers, and we might also call that a sub 1, right? It's the same. These are interchangeable, f of 1 and a sub 1. So I want you to recognize if you see a sub 1, it's the same as f of 1. And then we have to write the rule. F of n is equal to basically f of n minus 1, which this stands for, right, the previous term, and then that's multiplied by whatever r is. And in this case, r is 4, so that's going to be multiplied by 4. So this is the recursive rule for this particular geometric sequence, and this would be the same thing as a sub n. A sub n, f of n, same thing. Now for the explicit rule for this same sequence, f of n is equal to whatever f of 1 is, and all that times r. We have to know what r is. So here goes, right here goes f of 1, right here goes r, and the rest is n minus 1. So we know r is 4. and we know f of n, or f of 1, or a sub 1, is 5. So this is 5 times 4 to the n minus 1 power. Or basically 5 times 4 to the n minus 1. And that's the same thing as a sub n. A sub n and f of n are the same thing. So I'll give you a perfect example here. If this is my explicit formula, 5 times 4 to the n minus 1 power, and I plug in 5 for n, right, you're going to find that 5 times 4 to the 5 minus 1 power is going to equal 1280. So I'd like you to try to do that on your calculator right now. Now this is, you're basically going to do the part with the exponent first. So 4 to the, essentially the 4th power is equal to 256. And it's to the 4th power because what's 5 minus 1? It's 4. So 4 to the 4th power, 256 times 5 is equal to 1,280, right? The same figure you got here. So using this explicit rule, of course, we could find, any nth term. So I'm going to move on to the next area of the notes, give you a second to write all this down, and then we'll scroll down to the next section for some more examples. Okay, so here's some more examples, right? First thing we have to do in all of these, like remember when we were doing arithmetic sequences, we had to find D, the common difference. Well, the first thing we have to do on these is find R, the common ratio. And so we can do that by figuring, well, what is 6 divided by 9? What is 4 divided by 6? And so on. And they'll actually all be the same figure because that's what it means. It's the common ratio. So it's the same between each term. So 6 divided by 9 or 4 divided by 6, right? These numbers here is going to be equal to a common ratio of 2/3. And so now I know my rules for the recursive and explicit. First step is I've got to find f of 1. And f of 1 is the first number in the list of numbers. Also equivalent to a sub 1, right? Just another way of writing it that we're introducing here that you have to become familiar with because future things with sequences will label it either way. So we found f of 1, it's 9. And then we have to write the formula. F of n is equal to f of n minus 1 times whatever r is. And remember, this just stands for previous term. So r is 2/3. And you're done. For recursive rule, right? If you have the first term and you know the rule, the next term will be 9 times 2/3, which winds up being 6. So now we'll do the explicit rule. Again, we have to know what f of 1 is. And I'm also just going to highlight back on recursive rule, this is the same as a sub n. A sub n and f of n are the same thing. So we know what f of 1 is. It's 9. It's the first number in the list of numbers, which is the same as a sub 1. And we know the explicit rule from just above in our guided notes. It's basically equal to whatever f of 1 is equal to times r goes here to the n minus 1 power. So we know f of 1 is 9, and we know r is 2/3. So that is essentially the explicit rule for this sequence. If you were to rewrite it without all my boxes and lines, right, it would look like this: 9 times 2/3 to the n minus 1 power. And that's the same thing as a sub n. You could read this: a sub n is equal to 9 times 2/3 to the n minus 1 power, or f of n is equal to 9 times 2/3 to the n minus 1 power. And you can test it out, right? If I plug in any of these numbers here, right, you're going to get the following numbers below. So the last example before we jump to the homework packet is same thing. Instead of finding the common difference, we're going to be finding the common ratio. So the common ratio is going to be equal to 21 divided by 3, or 147 divided by 21, or 1029 divided by 147, right, and so on. And so 21 divided by 3, the common difference, therefore, is 7. So now that we know r, we have to find f of 1. And we also know that's the same as a sub 1. So the first number in the list of numbers is 3. And from here, we write our formula. F of n is equal to f of n minus 1, which is math code for previous term, times whatever r is equal to, and r in this case is 7. And the explicit formula is the same thing. F of 1 is equal to 3, which is also the same as a sub 1. A sub 1 and f of 1 are interchangeable symbols. And then f of n is going to be equal to whatever f of 1 is times whatever r is to the n minus 1 power. So here goes f of 1, here goes r, and you're done. Right? So basically this is the same as 3 times 7 to the n minus 1. And I think it helps to isolate 7 by parentheses, just to help you remember that if you were working this out, you would plug in n first for whatever term you're trying to find, and then you'd raise 7 to that n minus 1 power, and then you would multiply by 3. So you'd multiply by 3 in the last step. So on to the homework packet, and we'll go through some examples, and hopefully this makes sense.